B. Rutherford. C. Millikan. D. Dalton. So if you look at this very well, mostly only assign an atomic number to an element. So it can never be mostly. Mostly did not work on anything like that. Then B, option B, Rutherford. Rutherford worked on characterizing them as tiny positively charged particles. Positively charged particles in the nucleus. It was first carried out by Rutherford. Positively charged, and that's I explained in the last lesson that positively charged nucleus was first carried out by Rutherford. We worked on that first concept. Then Dalton only worked on what? Atomic theory. So the suitable answer to that particular question is what? Rutherford. And that will definitely be what? Option B. Hydrogen bond can be found in a hydrogen sulfide. No. Why is it not hydrogen sulfide? Simply because hydrogen bond exists between what? A hydrogen and a highly electronegative element. This is not a highly electronegative element, so it can't be hydrogen sulfide. B. Hydrogen bromide. Hydrogen bromide. C. Hydrogen fluoride. Hydrogen fluoride. Then D. Hydrogen chloride. Hydrogen chloride can never be. If you check the reactivity C, you discover that fluorine is the most reactive of all the halogens. Take note of that. So automatically, fluorine, this is the order of what? Decrease in electronegativity, decrease in reactivity, decrease in so this is the decrease in reactivity. So the most reactive is fluorine. So that automatically, it could have been this, could have been this, but this specifically is not even talking about hydrogen bonding, simply because hydrogen has only one electron and cannot afford to part with it. So therefore, this one will be predominantly covalent bonding. So here we have bromine, hydrogen remain constant, but fluorine is the most reactive. That is why hydrogen fluoride is the most suitable option, and that is option what? Option C, hydrogen fluoride. That's the correct answer. Question 5. The type of bonding in tetraamine copper 2 ion is tetraamine copper 2 ion. Sometimes it might just be given to you, the compound might be given to you directly. And so when we talk about tetraamine copper 2 ion. So what is amine? Amine is NH3. Then you are saying tetra. Tetra means 4. So if you are saying tetra, that means you have it as 4 this way. Then copper 2. Copper is here. Then that means you have something like this, 2 plus. So this is the ion. So the bonding here is what? Remember I explained earlier that when you have a bonding between a metal ion and a nucleophile, it is definitely what? Coordinate covalent bonding. That is what? Dative. This is a nucleophile simply because there is what? It is efficient of what? Electron. And this one is a metal ion, and it is evident as you are looking at it. So automatically, when a metal ion, interaction between a metal ion and a nucleophile is what? A dative. That is electrovalent M. That is dative. That is coordinate covalent combination. And there will be no other option other than what? Option A, which is coordinate. B is electrovalent. No, there is no transfer of an electron here. Metallic. No, simply because metallic is associated with what? Interaction between what? Valence electron and metal ion. That is the force of attraction between a metal ion. Then covalent. This has nothing to do with share of a pair of electrons. So the only option that is suitable is option A, which is coordinate. Question 6. A metal X forms two bromides with formula XBr2 and XBr3. What type of bonding exists between X and Br in the bromides? So this one is not far-fetched. I said it earlier that when you have a combination between a metal and a halogen such that you have it forming XBr2 and XBr3, it's only a transition element or metal that can exist because of the fact that they have what? They are characterized by what? Variable oxidation state. So in that situation, a transition element, a transition metal is still a metal, and this is a non-metal. So the bonding between a metal and non-metal is what? It is what? Electrovalent bonding. So the answer here will definitely be what? Electrovalent bonding. So which one would be suitable? A. Metallic bonding. B. Ionic bonding. C. Covalent bonding. D. Dative bonding. So it will be no other option rather what? Option B, which is ionic bonding, because ionic bonding is also the same as what? Electrovalent bonding. Question 7. Which of these properties gives a solid its definite shape? What gives a solid its definite shape is strong intermolecular forces. And A, we have weak intermolecular attraction. No. B, high boiling point. No. C, high melting point. No. That's nothing to do with that. D, strong intermolecular attraction. And that is the answer. Because it is a strong intermolecular attraction that make them to attain or that conform them to that fixed position which they cannot what? Translate, because of what? The forces of vibration is so large or is so enormous that makes them not to be able to be mobile, and as a result of that they remain in what? A fixed position. So the answer is option D of question 7. Then question 8. An element will readily form an electrovalent compound if its electron configuration is. So we know that the only factor that can make an element to readily form an electrovalent combination is if it has one valence electron which it can donate easily, or which it can donate with ease. So let's see the option that we have got. Option A. Option A, 288. Option B, we have 284. 284. Option C, we have 285. 285. Then option D, we have 281. It can never be this, it can never be this, it can never be this, it will be this. Simply because electrovalent combination is attained as a result of the ease with which an element donates electron. So automatically, one electron can be donated easiest here. So that is why option D will definitely be what? The answer. Question 9. The property of chlorine which cause hydrogen chloride to be more ionic than chlorine molecule is its, that is electrovalency. That should be electrovalency because of what? The dipole. You know, when you have HCl, there's a dipole moment here. Dipole. So the dipole here is definitely going to be what? That means you are talking about a positively charged species and a negatively charged species. And which concept talks about positively charged, negatively charged? There's no other concept other than what? Electrovalence. Electrovalency. That talks about that concept. Electrovalency. There's the transfer. When a metal transfer, it becomes positively charged. When a non-metal accepts, it becomes negatively charged. So in that situation, option A, electronegativity, no. Because electronegativity is the ability of an element to attract electron to itself. It can never be electropositivity. That's the tendency to donate electrons. No. C, electron affinity. No. That's the tendency to add an electron Then D, electrovalency, which is the answer. So option D is the answer to question 9. Question 10. The weakest attractive forces that can be observed between two molecules is, that is, when a statement or a question is structured that way, the weakest attractive forces. There is no other one rather than what? Van der Waals forces. So option A, ionic. Ionic is not weak, in fact, very strong. Covalent is not weak, very strong. Coordinate covalence is also moderate, while Van der Waals is the weakest of all the forces. So automatically the answer is D, which is Van der Waals forces. I want to talk about shapes of simple molecules. Then here I have hydrogen, shapes of molecules. I have hydrogen, I have oxygen, I have chlorine, I have HCl, I have CO2, then I have water, then I have CH4. Now, these are molecules. In the case of hydrogen, we have hydrogen has, or let me put it like this, hydrogen has 1 electron, so it has the 1 electron here. The other one also has 1 electron, it has it here. So automatically, if they want to, before there can be a bond between them, a bond is as a result of what? 2 electrons. So when this electron combine with this, you have a bond. So automatically, it will now be like this. So what is this shape? It's linear, because it is like 180. It is making an angle of 180, so it's linear. So it is a linear shape. Then also oxygen. Oxygen is what? Oxygen is 6. No? 8. Oxygen is 8. Automatically, what it simply means is that if you have a particular oxygen, you have 1, 2, 3, 4.